Having nothing but trouble with computers and related stuff today.
So yes, welcome. This is Open Research Institute's project meetup, and what we do is we talk about what we have done and what we have planned to do. If we have any resources that we need, and if we have any roadblocks, anything that's in our way. And what I'll do is I'll turn the roundtable floor over to Aaron to tell us about anything he's got going on and what he's got planned. Thank you, Aaron.
Sure. Hey guys. Um, so I'm kind of in the same place I was last week. I did work on it a little bit, but what I'm trying to do is re implement in the processing system of the zinc a way to generate the dummy frames with an OpenCPI. I haven't made significant progress, but I made a little progress towards that. And that's what I'll continue on doing this coming week. So yeah, that's where I'm at. Not much to report this week. I did, on another note, study for my general. So I took the test on Saturday and I passed it. So yeah,
Hey,
so I upgraded my ticket to general.
wow,
Yeah,
congratulations. Right on.
thank you.
You're going to press on and get the extra?
Maybe in a couple years, but taking it little bit at a time.
All right. Well, yeah, it's a big step. The extra just gives you all of the frequency privileges, and I think that you would probably not find the test terribly difficult. So when you get around to it, then it should find that it's well within your ability to pass it. But yeah, general opens up all sorts of HF, and that's really
Mhm.
cool. So yeah, congratulations.
Thank you.
You bet. All right. And I think anything else that you need or want to share or
Nope, that's all I have for today. Thank you, Michelle.
oh sure, no problem. Yeah. And for folks following along, please go to opencpi.org to see what Aaron is involved with and the sort of things that you can do with it. It's pretty amazing. Cool. Okay. And I think Matthew, let us know what you've been up to. It's been a lot. Some very interesting things going on, but you have the floor.
All right, thank you. Yeah, so this last week, we had been using a tool called DESY, DESY RDL, for generating the VHDL RTL output from the system RDL descriptions. And that tool was working fine, but it didn't cover all the bases that we needed. So I was actually using another tool called Peak RDL to generate like the C header files and the documentation and a couple of things. So I recently discovered that Peak RDL had created or has now available a VHDL exporter. And so I switched all the design over to use the Peak RDL tool. Um, and so it looks pretty good that it has more of the fields and capabilities of system RDL implemented than DESI RDL did. So that's all looking good. And then as part of that effort, I've went ahead and I've fixed all the configuration status register clock domain crossing uh, stuff. So previously, when we first implemented, just to keep things going forward, moving along, I didn't worry about the clock domain crossings, but that's all resolved now. And that what's one of the nice things about with the Peak RDL, it has some more field properties put in. So I just I'm going to try and write something up on this, but instead of using the tool to generate the register itself, it generates you tell it it's an external register and it creates a request and ACK signals so that I can use those request and ACK signals to interact with the hardware. And in doing so, can create resynchronize the request into the modem clock domain and then resync the ACK back into the AXI clock domain. And in doing so, can resolve the clock domain crossing issue. So that seems to be working pretty well in simulation. I think we're going to hopefully see some good results in the lab today. And so those were the I think the two big things. Then just adding some more diagnostic registers. We'll continue with that. I think there's a few more things that we want to get added in. So I think that was my report for this week.
Yeah, that's a lot. So I have a couple of questions. One is back to Aaron because since the management of configuration registers like this is kind of a big deal, if you wanted to kind of like let us know if there's anything that OpenCPI does for this or how you handle it, that'd be great to know. And then, oh, go ahead.
Yeah. So it kind of OpenCPI has its own paradigm for configuration. So every component has its own set of properties. We call them properties. And those are essentially a set of registers that get generated in HDL that are controllable within the OpenCPI framework using the C++ API. So it's automatically generated based on an XML, which is the component specification, which you set the properties. So each one will have whether it's long, short, unsigned, signed type of thing. So in the XML, and then I'll get automatically generated into the OpenCPI way of configuring these registers, what we call properties. But it's not because it's adds to the component specification, what it's called. But yeah, that's how we deal with it.
Okay, yeah, that makes sense. So a component level specification or like to handle things like status and control registers through like an XML document. Okay, so it's really pretty familiar.
Yes.
So.
Yep.
All right, thank you. Yeah, I was just curious.
Yeah.
Yeah.
You're welcome.
No, and the bug that we're talking about, I call it a bug because it was an issue that's been on the issue tracker for a while about the concern about clock domain crossings. And that's always a ever-present thing with FPGA designs. If you have multiple clocks, you're going to have to figure out how to synchronize signals back and forth. And we've been doing a lot of work on that lately. And I think that issue is now closed. So that's something that's now you've put it to bed, Matthew. It's now off our desk, basically.
How about now?
Yeah, now it's working.
Oh, okay. That's weird. Anyway, very good. So yeah, I was able to close that issue because we've been incorporated all the control signals and status signals through clock domain crossings now. But I think Aaron has a good point. It was something I was thinking about yesterday. What I kind of want to do as we move forward is move the RDL, and instead of having a top level RDL that's everything, I want to create RDL files for each of the subcomponents. And then what you can do with system RDL is you can then, in the top level file, you can include all the subcomponents. And so in that way, the RDL is specific to the subcomponent and travels with the subcomponent. But then at the top level, you would kind of, can do, it's more of a Verilog syntax, but a tick include the component level files. And that way, we keep those register specifications as part of the component. So I'd like to move to that paradigm here as we move along. But I think that's a good point. So it kind of becomes more hierarchical and does it better than document what's happening in the component in terms of its configuration and status, because it's there with the component itself.
Okay, no, that makes a lot of sense. And just the reason that most people understand why you want to have register access. You want to have control and status registers. You want to be able to read back something that's going on in your design. That seems like there's lots of examples of that. And you want to be able to reach in and say, okay, now do this, to control things. At the very minimum, you want to do this when you bring it up. Like when you turn the radio on, you want a set of instructions given to your radio. And it might be different for different operators and different situations and different deployments, but you want to be able to say, okay, here is what you're going to be doing, and here's your configuration, and then let me know if the status changes. And so, these things are super important. The next batch of work that we're talking about doing in terms of like opening up more or increasing the number of status and control registers is to give us some visibility into the frame synchronization. So now we're going from a streaming, just streaming the bits along and making sure that the modem is working to, okay, now we're frame aware. And then that opens up all of the different parts of the protocol that we're implementing. Um, and then there's a couple of things that we need that Matthews enabled, made it possible for us to have access to. So that's what we're trying to get up and running in actual hardware now. So the frame aware stuff, like frame synchronization, whether have you gotten frame sync or not, what's going on with your FIFOs, that sort of thing. And then kind of beyond that, we've talked about having, so those are status registers that report back like what's really going on so that you can see, so we can get the design working in hardware as well as it's working in sim. But the other part that we're talking about doing is to configure the radio to give us a lot of flexibility to realize the full potential of the modem module approach that Matthew's outlined. Is that okay? So you have all these things that you can do if you have a very small FPGA. I would say the 7010 is probably on the small side. Then maybe you just want to let the modem handle the modulator and the demodulator, the modem, and it can handle the framing because we've already got that in there. We can prove that it can fit into the 7010, and maybe a little bit more, but we're getting kind of close. That's a pretty full 7010. And then if you have a 7020, oh, you can put other things in hardware like the randomization, all the buffers for that, and the forward error correction, interleaving, and then maybe more. And so there might be, it seems like this would be a good candidate for a control register that said, okay, how much is actually going to be in the design to somehow, do that. So that may be a configuration register. I think most people know like what FPGA they're going to be getting. So this may be just me being too enthusiastic about flexibility of a design, but we could provide this, at some level if it's not strictly a status register or a configuration register that we would be
Usually
able to.
for those types of variations and builds, which you might have for different FPGA sizes, I would typically use like generics or some other build parameter to select what's being built in. Because if it's a smaller one, you won't have all that other stuff there anyway, right?
True.
Yeah. So
forgive the enthusiasm for the
yeah. No, but you know what? But
I'm like, oh, we
what
can
is good
configure
there?
this.
What is good there is a status is part of a as a status register is identifying what is there. So so it'd be nice like the software it may not know what the FPGA is, right? And it doesn't know what's in the FPGA. So
Yeah.
the software would know what it needs to enable or not enable from a software perspective.
Yeah.
So one of the things I've done in the past, and I have going to implement it here, but I just haven't quite yet, is there's also this issue of how do you know when you have an FPGA in the lab which version of the FPGA it is. If you if you do 10 builds a day, which one's on this device? And it's not always easy to know which it is. And so you're testing something, you don't know if you're testing the right thing. So what I intend to do is when the FPGA is part of the build process, we create a 64-bit hash, and that's unique per build. And then you can read that hash back from a status register. And then, if you keep a table of the build, here's the hashes I built and here's the versions. Or if you can even include them like in a tag in Git. So you could say, this build was this hash. So there's some way you have a configuration management to know what the hashes are, but at least they're tied to an FPGA so that you can know what you're actually testing. But then, to extend that to what you're talking about, what I would see and suggest would be we could have a status register that say is FEC included, is framing included, so you could read back and know what that FPGA's capabilities are. And so then the software can configure itself accordingly.
Yeah.
Yeah. So a lot of the things that you guys are talking about have some sort of solution already within the OpenCPI framework, because like you said, that you don't know what device you want to execute on. But and you can build for multiple platforms at the same time. So it has so that's why it's a component-based architecture. So it can provide you that flexibility of what you're running against, whether that be the FPGA or the CPU. And at runtime, OpenCPI allows you to discover like, hey, this is what's connected to me. This is what the app, there's an application specification. This is what I want to run that to a library of components, objects that get specification and basically says, okay, this is the work, this is the MSK modem that I want to implement, but it doesn't necessarily doesn't pin down where it's running. But when you execute it, it goes, okay, what FPGA is available to me, what processors are available to me, and then what library of pre-built stuff is available to me, and then it figures out, okay, I have a 7020, I can, and this bit stream is already built for this platform. Go ahead and load it on at execution time, and then connect the software components to communicate to that FPGA right off the bat. So it has that flexibility of being able to target multiple differing platforms, whether it's a 7010 or 7020. On the 7010 case, it won't have all the functionality, all the components embedded in the bit stream. So then it finds the software equivalent to execute that application and then that on the CPU, everything 89363, and it's off to the races. So a lot of this of the functionality that you're describing already exists within the framework. Is just understanding the porting it to the, I guess, the syntax, the XML documents I've been explaining, and then some of the intricacies of the framework in order for all that magic to happen in the background.
Yeah, thank you. That's a very powerful description. I think there's a whole lot of overlap here between what we are realizing we need to do and what we've started to manage better from Matthew's efforts, and what OpenCPI has to offer. So yeah, thank you so much. That's oh, it's good. It's I think the message is like we're on the right track, but it exists, and you know, we should probably investigate a little bit harder and figure out what we can get some traction on. Yeah, okay, back to you.
Oh, I'm done.
Okay.
Unless there's other questions that you had on how it works.
Oh, I'm sure I can come up with plenty. No, so
okay.
no, thank you so much. No, Matthew, anything else?
Yes, I am. No, I think that covers it so far.
Yeah, no, it's a ton of work. Thank you so much for all that that you're doing. Being able to actually see this stuff and to have a, you know, the system RDL, the register descriptive language, is pretty powerful. For me, the biggest step forward is pretty simple. It was that I did not have to manage like a header file or re-establish, redo the register accesses in code over and over again. That I could just go to the repository, get the header file, use it in my code, look it up on a really nice markdown document or a PDF, and then it worked. And what a relief, because it made the first number of versions of the processor side code like actually enjoyable to you can focus on the actual problem rather than trying to debug the register map and all that. So thank you.
Yeah.
Good stuff. All right, and now we did cut a build yesterday with all of this, lots of updates and changes and everything. Delivered that that build to Paul, and you have the floor to tell us how things went.
Well, not that great.
Sorry.
I loaded the new build onto one of the Plutos, the one we used for transmit and RF loop back when conditions permit. And it didn't quite brick it, but it's not working. That Pluto is now refusing to respond. It sort of like it tries to reboot and then it loses track of what it was doing and throws up its hands, and it seems to be in a boot crash loop. If I monitor its presence on the USB bus using LSUSB on the Raspberry Pi that the Pluto is directly connected to, then I see it coming and going, coming and going, coming and going, coming and going. And it's coming
Hey,
and going
hey
fast enough.
Paul,
Yes.
do you have it externally powered, or is you getting the power straight from the USB? Because I've seen that symptom before. If I have something on the bit stream that's using more power than it normally does, that if I have the DC power block connected to that second power plug versus just taking power and data from the middle, that that might, I don't know,
Okay, that's a
if you
good
have it
suggestion.
externally
It crossed
powered.
my mind that it might be a brownout problem, but we've been running with these Plutos in this configuration for a long time and not had a problem. Maybe we finally crossed a power consumption threshold that makes it important. I will try that. Um,
Yeah.
so the answer is no. I haven't been powering them independently. I've been powering them directly from the Pi using the same connection as the data connection. Um, anyway, if that doesn't fix it, then what's left is trying to get control of the upload process before it crashes again so that I can upload some firmware that doesn't do that, assuming that it's the firmware problem and not just a coincidence in time. Um, there's one way left that I haven't tried, and that's to use the DFU mode. DFU mode has three ways it can access the system. Uh, Two of them are equivalent to ways I've already tried that require the software to be running. And the third way, which I have yet to try, is to hook up to the UART console. The UART console is not populated on a Pluto board when it comes from the factory and requires a special little adapter board called a ADALM JTAG UART or UART JTAG. JTAG UART, I think. Um, we have one of those little boards and we have equipped one of our Plutos with that connector. However, it's not the one in question at the moment. So I ordered some connectors, or at least I thought I had ordered some connectors yesterday from DigiKey. Turns out I was one click short of having completed the transaction. I saw a notification come in from my credit card and it said, you know, DigiKey has sent you this or charged your credit card. So I figured, well, I must be done. And I quit and went to bed. And this morning I still hadn't received any email from DigiKey. So I went back and looked and I hadn't actually clicked the last button. It had actually only charged my credit card for $1 to see if I was really there. Um, so I've got some of those connectors on the way. It usually takes a couple of days with DigiKey, and then I'll be able to plug in the connector and see if I can get control of that Pluto. If not, then I don't know what I'm going to do with that one. There may be no way out. Um, we'll cross that bridge when we come to it. We do have several other Plutos we can use, although I'm a little reluctant to burn through them with experiments. I notice that Plutos are not in stock at the moment at the usual distributors. I don't know why. There's a few hundred of them expected in December. So I'd rather wait a couple of days now to try what I think is the recovery path than to burn up another Pluto.
Right. Yeah. In case it's a problem with the build environment, since I'm doing the builds, uh, and uh, there was a lot of things that we did we went through a lot of things that don't bother simulation, that aren't a problem in simulation but do show up in synthesis, and so fixing those bugs, it's all on GitHub, so there's a series of changes that were made. Now it's just made to source code, but if there was anything that the build environment did to mess this up, what I did a full make clean, and I like wiped everything away. It looked really good. That's the build from this morning. Um, if you're if you're feeling you know brave in any way to try it on another one of the Plutos, then we could, or just look at it and see if it's any different than the one that you got yesterday. And if it is, then that's a potential clue. There shouldn't have been anything that was done in order to change the register access, uh, the RDL stuff. I can't think of any reason why it would brick Pluto. If we have discovered some sort of very interesting bug like this, then I absolutely know that like Peak RDL people would really want to know about it. So especially if it's something we can duplicate, that would be uh, a pretty big report, I think. So anyway, that's something maybe to try to look at the two different versions, the one from yesterday and the one from today, and see if they're different at all.
Look at them. I can do a bitwise compare. If
Yes,
they're
a
not
bitwise
bitwise
compare,
identical,
like to see if the binary, or not really a binary, but to see if the delivered Pluto.frm is different.
don't think we ever get bit identical builds when we build again.
Oh, yeah, that's a
Somebody
good
can
point.
correct me on
Okay.
that. I think there's always some hashes and or timestamps or something
Okay.
that are
Yeah,
going to
so
be
that might not
different.
be a reliable indicator. Anyway, I'm very sorry about what happened, and it's okay if you because I think we have four Plutos that we can work with, maybe one more. Try one more and see. It could just be a coincidence that it decided to go toes up on us right when we changed something major. You
It
know,
could be.
yeah, it's sort of so this is like the are you kind of the spy or are you the scientist? So a scientist, there's no such thing as coincidences don't matter, you know, uh we just assume that we're going to get coincidences and we disregard them and we keep working, and a spy is like if it's a coincidence, it always matters. So it just kind of depends on your point of view as to how suspicious we should be. So
Or an alternate view taken from Doc Smith's science fiction is once is happenstance, twice is coincidence, the third time is enemy action.
enemy action. Okay, well, 3 out of 4 ain't bad. So I,
We have two Plutos that have the clock connector on them, and
oh,
one that's in injured reserve right now
yeah,
is is one of them. So if we burn up, well, even without burning up one more Pluto, we can't do the clock to clock uh, syncing, which is sometimes handy. Hopefully, we're beyond it right now, but I've been using it as a way of, eliminating one more uncertainty.
right. Well, never a dull moment, right?
Never. Aaron, do you know offhand what kind of current requirement is safe for the Pluto for
I
a
think
certain
it's
power supply?
2 amps would be fine, sufficient. I know the USB is either 100 milliamps to 500 milliamps that it can deliver, depending what device you're delivering it from. But I've connected the either 1 or 2 amp 5 volt supply to the DC. It's another USB connector, micro USB connector
Yeah,
on the right to
unfortunately.
provide just power.
Okay. I'm pretty sure I have a brick or two like that lying around. So I'll try that as soon as we're done here.
Yeah, I have some 3 amp ones from the art projects. So if you come up empty, let me know.
Okay.
Cool. Yeah, no dull moments. Yeah, thank you so much. Is there anything else going on that you want to talk about, Paul?
Um, well, some details, I guess. What we were hoping to get to. Um, no, let's not talk about that right now. I have to think about it to remember what we're doing, and that would hurt. So
Okay, very good.
another day.
Understand. Okay. Well, no, thank you so much for all of your help and support. And it's been uh, a really good week. Um, Lots going on with the infrastructure, and it's all working great for me. So thank you so much. We're looking at so we have a party in the lab essentially on Halloween. So there's a Halloween party for the local DEF CON group, and big thank you to Paul for enabling open house of the remote lab and to invite people to maybe give a little bit of pen testing to the way that it's set up, so that we might have a little bit of a CTF going on. So if anything cool happens, we'll be sure to tell you all about it, and the any improvements in the remote lab configuration would be good. Occasionally, we do see some weird behavior, so that'd be great to get any insight in on that. So some of the things have been going on are, so the Pluto MSK repository has this branch that is handling an update to the way that we handle the register. So the register descriptive language, the Peak RDL branch. The other current branch that's being worked on is called sync detect. And this started out being just an attempt to kind of like say, okay, we have this modem that handles the stream. Now we need to look at frames, and frames require sync words or some sort of synchronization detection. So the standard way of doing it is to have a predetermined, known in advance little chunk, little digital, binary sequence. And this is something that you look for. And there's multiple ways to do this. And we're starting out with a pretty simple approach, and we're going to ratchet it up as far as we can and document the whole thing. So that branch is what I've been involved with. And things are working really well in simulation. Things are not working really well in hardware. So as of today, I don't think that we've seen a real synchronization, a frame synchronization detect in the Pluto. Is that right, Paul?
Yeah, that's right. We have not.
Yeah, and this is very confusing because like the simulation looks great. Everything's working as you would expect. What you do for a relatively simple approach is that you, as the receiver, you're sitting there and you have a shift register, and our sync word is 24 bits long, so we have a 24-bit shift register. All of the demodulated bits, which are accurate and awesome, thanks to Matthew's work, come in. We sit there and we go through the shift register, and we know the pattern that we're looking for. And so as soon as that pattern matches, then we go, yes, this is the start of the frame. And then after that, all of the next 268 bytes then go, and they're considered payload. Now, previously, we were just looking all the time or just watching for sync words. And this actually is not the best way to do it. If you really kind of dig into this and pay attention, then it's like, oh, there's a lot of false alarm rates. So what you do is that, when you first start up, when you fire up and you're looking out at the world of radio waves coming at you, you go, okay, I'm going to demodulate what I'm supposed to demodulate. Oh, look, okay, this looks reasonable. Now I'm going to hand it off to look for the sync word. And then you get a hit. At that point, you then say, okay, I'm going to come back after 268 bytes and I'm going to check again. And I'm going to see if there's another sync word. That's the much better way of doing it because it then reduces the negative impact of false alarms. Because, 24 bits sounds like a lot, but when you look at the statistics and, 54 kilohertz bit rate, you're going to get a lot of potential sync words, even though we've done all that we can to reduce that by randomizing, by interleaving, all that sort of thing. So, we're like, okay, got it. So what we've done over the past week, to report like the work done over the past week, is we wrote an entire article about this and kind of documented our search for what's the best possible sync word. So we did that. But we also implemented the new sync word into code and started the process of making it a little more maybe adult, a little more a better way of kind of doing it. So the current design in the repository, in the branch, sync detect is you're going to just search every bit that comes through the shift register. We look for our sync word. And when we find it, we say, okay, good, mark. And we check back in 268 bytes. Oh, we found it again. That's great. Then we check back again. Oh, we found it a third time. Now we have got sync lock. And now we can relax our requirements a little bit. We back off a little bit. And if we get maybe a partially damaged or an okay sync word, then we keep it up. And all the frames just go by. Now, if we lose sync, we actually wait a little bit. We wait for 2 frames. And we say, maybe a crash is static, kind of marginal, high, bad SNR, whatever. But if we get to 2 missed syncs, then we go, okay, now we're going to search again. And this is a good baseline design, and we'll measure the performance and everything. How did we choose the sync word? So the sync word is chosen to be as good as it possibly can be, and at 24 bits, then you're looking at what we would call a peak to side lobe ratio of 8 to 1. And we exhaustively searched every single sequence of 24 bits to find the ones with the best statistics. And that's what we got. The one that we were previously using, which was concatenated Barker codes, is not bad at all. It's actually not a bad sync word, but it's got a ratio of the main, when you actually match, you get all 24 bits matching, but there's these side lobes that happen. So as you're shifting it in, you get these partial matches. And those side lobes are high enough to where the ratio is only 3 to 1. And so with enough noise, you can sort of see that, like, oh, you could get some fake matches that are off a byte or two, or off a byte. And we don't want that. So that's why we went to the best possible sync word. Now, where does this matter the most? It doesn't really matter with additive white Gaussian noise. And the article that we wrote over the past week kind of outlines that and kind of shows it. But where does it really matter? It really matters with multipath. So since we're looking at UHF and above, we have to deal with it. So our frame sync marker, the thing that tells our receiver where the frames are, is set. It's now the best it can be for dealing with the sorts of frequencies and situations, deployments that we're facing, that we're looking at in terms of terrestrial. So terrestrial multipath is a big deal. We're good, and the article draft has already been on Slack, and I'll put it out for the mailing list, and we'll put it in the newsletter next couple of weeks for the next newsletter. So that's the news. That word, just changing the 24 bits in the code was all it took. So all of the stuff that I've talked about and all the reasoning, it's a very small commit, right, to update the sync word. But it's backed up by a lot of work. And then the process of going from a very simplistic sort of interruptible, oh no, now we have to search fully and suffer a lot of false alarms. That sort of work going to like a little more like, okay, like wait until you get multiple failures before you start searching again. Wait until you get multiple successes before you declare a lock. This is all industry standard, very well studied, supported by good science. So we're definitely on the right track. And there is a bug. So the current issue is that the second frame doesn't find the sync word at the right spot. It's a byte off. Every other subsequent frame is fine, but so this points directly to initialization error in the code. And we're going to track that down over the next week, and we'll have it solved pretty soon. So it's pretty obviously initialization error because it self-corrects after a bad frame, but we don't even want one bad frame. So we're going to track it down. So the two branches that we're working with now at Pluto_MSK are the RDL to update the registered descriptive language. And as Matthew mentioned, the clock domain crossing weirdness, which did have a potential to corrupt your register access, big deal, has been resolved. That's fixed. And there's ongoing work to try to make sure that those changes didn't also make the firmware weird and brick the Pluto. That would be kind of bad. So we're going to keep tracking that down and work on that. And then the other branch is about sync detect. And looking out a little bit further, we've got tons to do. One of the things that we talked about is the forward error correction. We rely on convolutional or Viterbi encoding decoding at a rate 1/2. This is very well studied. We are very confident that this will give us 6 to 8 dB of coding gain. That's a lot. That's great. Matthew raised the possibility of looking at something called spinal codes, and those are very cool, more complicated, possibly closer to capacity, and that's something that like the register accesses that we're talking about, like a configuration register, like to tell you, gosh, what what forward error correction are you using? Let me tell you what you should use. That's the sort of thing that the sort of the register map that we're anticipating might be able to handle, multiple different types of forward error corrections so that we can compare them. So convolutional codes are very well studied. They're backbone, sort of the spinal codes, get it? Sort of reference there, especially with Halloween and all. But that's what we're talking about doing, and that's going to come up pretty quick. Another thing that's coming at us very quickly is the receiver side for the space segment, essentially the high Fourier receiver. And we do have some pretty solid work there with the EZS cores and the receiver, but that is a big FPGA development effort, and that is looming. That's in the future. All right, so I'm going to pause here for any questions about anything I've said because it was a lot, and then talk about the AMSAT UK FPGA project. Okay, so I'll let you guys know what we're doing and the exact shape or the way that this project unfolds from here might change a little bit, but the actual project itself is firm, and we are working with AMSAT UK. This is the UK amateur satellite folks, and they have a really neat satellite, the FunCube Plus. This is the next generation FunCube satellite, and this will go up in the future. And they have space on this payload, and they are very interested in doing something called an MDT. That's the shorthand for this particular project. This is an FPGA-based project, and it's a mode dynamic transponder. That's the expansion of this acronym. The idea is to kind of use low Earth orbit satellite in order for digital amateur communications. I'm going to read from my notes here so I don't get it wrong. And what we're doing is that we can assume that the uplink modes from the ground to the AMSAT UK satellite can be fast. That these modes can transmit pretty fast. There's the digital modes, and that the spacecraft then can meter out these communications at a slower rate. Now, anybody that's been around an amateur satellite for a while might find this to be a familiar pattern. For example, BBSs in the sky, packet transceivers or transponders, or anything else, so that you want to essentially honor the power budget of the satellite. Now, a volunteer at AMSAT UK has been working on this and has a bill of materials and block diagrams and a design for this, and could use some additional help because the schedule for the launch or for completion and doing all of this, and the available folks might not, they need more help. So I said, please count us in for assisting with this, and this is moving forward. And I asked if it was okay to talk about this at our weekly meetup. I was told absolutely yes. So I'm going to report to you what we've offered to help with, and to put out the call for anybody that might be interested in this sort of work. So right off the bat, you can kind of tell this is a little bit different than what we're doing with opulent voice, a little bit different than what we're doing with high Fourier. So if you are really interested in this sort of work and you would like to support it, and all of our we've got board members that have already indicated, yes, this is great. We're going to move forward and as an organization and support it. So if you're a volunteer or interested in this sort of thing and you would like to learn more, then this may be a really good project for you to get involved with. So please get in touch and let us know, because it's good. This is anything that has a launch is exciting. So yeah, please let me know if you're interested. And as soon as I know anything more than what I've just shared, I will pass it along. Looking forward to meeting with the volunteer, the AMSAT UK volunteer that's been working with this. We want to honor and support their work and make them as successful as possible and move forward and get this up and in orbit and on the air. All right, I think that's my report.
Hey, Michelle, you mentioned there's blog diagrams and things, documentation like that. Has that been shared with you yet that we can point to?
Yeah, it's on the way, and as soon as I get it, then it'll go out in all the places that I can put it to get as many eyes on it as possible. So I don't know much more than the work has been shared with AMSAT UK, and they were excited about it. It's already included as part of the payload, and yeah, we're committed to help make it happen. So that's what I know. So yes, as soon as I actually get any of the artifacts, then they'll
Yeah,
be shared and passed along.
sounds great. Thank you.
Yeah, I'm looking forward to this. The experience with AMSAT UK has been very positive. They were very kind to include a presentation from us about our work and the opulent voice, Hypharia, the DVB-S2 encoder, things that we do, regulatory work. And this was very well received and got lots of comments. Because of the time zone difference, it was a pre-recorded presentation. So maybe next year we'll be able to experience it in person. So it sounded like a good event. Yeah, thanks everybody. I'm gonna go ahead and I'll turn off the recording. And thank you everybody for all of the attention and everything that you're doing. We do ambitious work, and it could not happen without all of you all and all the folks out in the community. We're putting together the next newsletter, so if you have anything to share, please let me know. We just want to get the good word out.